welcome to lecture number 21, section 3.14. So this is solving linear inequalities. So they're lines, but they're not just regular equations, they are inequalities. And please note, these are not on your exam. This section is optional, but we are going over it. So the first property, if you have A less than B, which already represents a true inequality, so a true statement, and if the same quantity is added or subtracted from both sides, or both sides are multiplied or divided by the same, and this is really important, the same positive number, okay, it has to be positive, then the resulting inequality remains a true statement, and the direction of the inequality symbol remains the same. Okay, let's take a look first at examples that do not have any variables in it. Okay, we'll use examples later on that do have variables, but this is just to show you how the statement does remain the same. So first, let's go ahead and add the same number to both sides. But before we start that, is 15 actually greater than 6? The answer is yes. Okay, so we already know it's a true statement, so let's go ahead and add 1. How about let's just pick 1? You could have picked any number, but let's just add this. So that's going to be 16. Is 16 greater than 7? Does that make sense? Yeah, it is. 16 is greater than 7. All right, so it holds when I add a number to both sides. How about if I subtract a number? Let's look at B. First off, is this statement true? Is -4 less than 10? Yes, it is. All right, so we know the statement is true. Let's go ahead and try the subtraction rule on this one. How about I'll subtract 5 from both sides? Once again, I just picked any random number to subtract. So then I have -9 is less than 5. Is this a true statement? Is -9 less than 5? The answer is yes. All right, so the property still holds. So now let's take a look at, let's go ahead and multiply. We can use the multiplication. So multiplying both sides by, let's go with 2. Multiply by 2. Oop, before we do that, let's check. Is 5 greater than 3? Yeah, 5 is greater than 3. So now let's go ahead and do the multiplying by 2. So then we get 10 is greater than 6. Is that true? Is 10 greater than 6? Yeah. So what we learn is if we're adding, subtracting, or multiplying, this also goes with dividing, and a positive number. Any one of these cases, the sign of my inequality remains the same. And that's one of the key components here that we're going to look at that will differ for property 2. So in property number 2, if A less than B represents a true inequality, and both sides are multiplied or divided by the same negative number, then the inequality symbol in the resulting inequality statement must be reversed. Okay, so if it was a less than, it got to move to a greater than, or if it was a greater than, it needs to move to a less than. So you might be like, what? Why? Well, let's take a look once again at these problems without any variables. So, is 15 greater than 6? Yes, that's true. Let's multiply this by a negative number. How about -1? So -1, -1. So that is -15 is greater than -6. Is that a true statement? Well, let's look at the number line. Here is -6, and then we would count back a bunch of times until we got to -15. Now this inequality is saying that -15 is greater than -6, but that's not true. This statement is not true. So we run into a problem here. And to fix that problem, what we do whenever we multiply or divide by a negative number, we simply reverse the inequality sign. So let's see, does that actually help? We get -15 is less than -6. That's true. We showed that with the number line. -15 is down here, and -6 is over here. So when you multiply or divide by a negative number, in order to make the statement turn out to be true, you need to flip the sign. Okay, flip the inequality sign. All right, so let's take a look at this next one here. Is this a true statement? Is -4 less than 10? Yeah, it is. I'll go ahead and draw that on the number line. negative 4, oops, not there. Negative 4 is less than 10. So, if I multiplied this by some random negative number, how about negative 2? I would get, well, negative 2 times negative 4 is going to be negative, or positive 8, which is less than 10 times negative 2 is negative 20. So, if I don't flip the symbol, this is saying that 8 is less than negative 20. That does not make sense. Negative 20 is somewhere down here, and 8 is over here. 8 is obviously greater. So to make this statement true, remember we need to switch the sign, which means we would get 8 is greater than negative 20, which is a true statement. All right, go ahead and try, let's multiply the last one by, I'll pick negative 5. Oops, I want a different color. So then I get negative 25 is greater than negative 15. Does that make sense? No, it doesn't. We're going to have to flip that symbol. So negative 25 is less than, oops, that was really ugly. Negative 25 is less than negative 15, which is now a true statement. All right, so the main thing to note here is if you're multiplying or dividing by a negative number, you need to flip the symbol. Okay, flip the sign, flip the inequality sign. So we have some inequalities that now have a variable in them. All right, so the first examples were to show you why we have these strange rules, and now we'll actually use them. So solving A, we're going to solve for x. X is currently right here being multiplied by a negative 2. So to get rid of that negative 2, we're going to divide by negative 2. But when we do that, remember, to make it a true statement, we need to flip the inequality symbol. Now, most professors will get, will probably take a few points off if you don't flip immediately when you're doing the division on your work. Okay, so please make sure you do that. Don't flip it on the step after. Flip it immediately when you show the division. Okay. The reason why is because you're trying to make this a true statement. All right, so then we have x is less than 4 divided by negative 2. So x is less than negative 2. And there we go. So for the next one, we have a greater than or equal sign. And we're trying to solve for x, and x appears in 2 places. And one of those places, it's in a parenthesis. So let's go ahead and get rid of that parenthesis first. Oops. Multiply the 4 in, and we get x minus 3 is greater than or equal to 8 minus 4x. All right, let's get x on the same side, so I'll go ahead and add 4 to both sides. Now remember, when I'm adding, I don't need to worry about flipping the sign. Okay? The sign stays the same only if you're only if you're multiplying or dividing by a negative number. All right, let's get the 3 to the other side, so let's add 3. So then we have 5x is greater than or equal to 11. Okay, I gotta get x by itself, so let's go ahead and divide by 5. Oh, do I need to flip the inequality symbol? No. I'm dividing by a positive number, so I do not need to flip the inequality symbol. I'm all good. Okay, continue this over here. So then I have x is greater than or equal to 11 over 5. And unless they ask you to answer in a specific way, that is a good simplified fraction. And the last example for this problem. So go ahead and pause the video and try and see if you can solve this by yourself. Alright, so hopefully you tried this by yourself. I notice x is in 2 places, and one of them it's in a parenthesis. So let's get rid of that parenthesis first by multiplying the 2 in. Alright, so then what do I have? I have 5 minus x is less than 2x minus 6 plus 5. We can go ahead and add these like terms right here. And we will get 5 minus x is less than 2x minus 1. Okay, let's get x on one side. So I'm going to go ahead and I'll add x to the other side. We're just trying to combine. So combine on either side. You can combine to the right side, or you can combine to the left side. Either side works. And then I have 5 is less than 3x minus 1. All right, got to get rid of that minus 1 there. Let's go ahead and, wrong color pen. Add 1 to both sides. I get 6 is less than 3x. Okay, last step. We're going to need to divide by 3. Divide by 3. So we have 2 is less than x. All right, and the last thing that we did not do yet, we need to answer all of these with a graph. So what do I mean? Well, here's a number line, and for me, what I just want you to do is indicate where 0 is, and then where your number should be. So for this problem, we're working with -2 as our boundary. So -2 should be on the left side of 0, so just go ahead and write that in. Some professors want a bit more tick marks. I'm fine, as long as you write with a 0, and then where your boundary is. And then we know that x values are going to be less than the -2 values. They're going to be less than, and they're not going to be equal to. So we go up to the -2 boundary, but we're not going to fill it in. We would fill it in if it was equal to. Okay, so we're not going to fill it in, and we know all the values of x are less than -2. And we put that arrowhead to indicate all those values off into that distance. All right, so for B, let's go ahead and graph the number line once again. Just to indicate where 0 is. And then I know it's a positive number, so 11/5. Now, this says x is greater than, which means it's going to be numbers on this side. Oops, wrong pen once again. On this side of 11/5. And it's also equal to. Okay, so when I draw our little bubble, we're going to fill it in this time because we're allowed to have 11/5 as part of our solution. Okay, so notice one thing. I tend to float my graph above the main number line. The reason for that is sometimes if you try to draw it here, it's harder to see your answer. So I like to float the answer above. Some professors don't like that. Some professors like it. I tend to like the floating answer. Depends on your professor. All right, so try and graph the answer solution for this last one. Pause the video and then check back in with me. All right, so boundary of 0. 2 is our boundary. +2. We know our x values are greater than that +2. So we're going to go ahead. We know that they're greater than +2, but they're not actually equal to +2, which means we're not going to fill it in. We're going to leave it as an open circle. And that is it for inequalities.